And thank you, uh, respected HOD, Dr. Shalini. Thank you, respected Principal Dr. Maniarasan. And thank you to Honorable CEO, Dr. Krishna Kumar. So when I was asked to give this webinar, I have two choices. One is to talk about my research, which is how I synthesize nanoparticles, how I put organic ligand on the surface of the nanoparticles and study the plasmonic effects. So that's my research that I've been doing for years. But that involves a lot of chemistry. But I heard most of the audience would involve faculty and students of science and engineering, which may not be a chemistry major. So I chose the other option, that is to talk about general science. That is very related to every one of you. So I'm going to talk about the climate change today. What causes climate change, the science behind global warming and climate change, and how you, faculty and students, can try some of these lab experiments in your own laboratory, right? So for the first 30 minutes or so, we'll discuss the climate science in a very general way. So don't expect a lot of technical details in it. I treat this as an awareness webinar, right? So I would like you to receive in the same way, right? It's an awareness webinar. And at the end of this webinar, we'll watch a video of some lab experiments that you can try in your own class, okay? So I'm going to share my slides now. Okay, let me check if... Okay, do you see the slides?
Yes, sir. It is visible, sir.
Okay, thank you. Give me 1 second, I'm fixing something. Okay. Okay. So meeting climate changes. What is climate change? So we sometimes get confused between weather and climate. Weather refers to the atmospheric condition that occur locally over a short period of time, from minutes to hours or probably days. The familiar example of weather include rain, snow, clouds, winds, flood, thunderstorm. So these are weather that changes every day or every week. But climate, on the other hand, refers to the long-term regional or even global average of temperature, humidity, and rainfall pattern over seasons, years, sometimes decades. So we are talking about this big range, not the weather, but the climate, right? So weather is a long-term, climate is a long-term effect. So the extreme heat is the first thing we can obviously see due to this climate change, the extreme heat and the deadly impact of that. So that is the heat that is observed throughout the globe for a few decades, right? It causes deadly impacts to human beings and other living things. The next thing is the intense weather pattern, right? The sudden change of flood, drought, cyclone, heavy rain, humidity. So these are intense weather that we have been experiencing for last few years or few decades, right? We have seen a lot of floods even in the southern part of India, and a lot of droughts, right? And then next thing is melting polar ice sheets, right? Due to the global warming, the ice in the polar region, either in the North Pole or in the South Pole, are melting at an alarming rate. And that is, again, because of the climate change and the rise in sea level. Because of the melting ice and increase in temperature, the sea level will rise, and maybe in the future, most of the coastal cities will be under the sea. And a very frequent and longer droughts, right? And because of the flood and drought, people and animals displaced from their own native place into a different territory. And lack of food supply and severe health issues. So these are the definitions or effects of climate change. And it's very obvious. We have been experiencing, every one of you might have experienced this personally. Okay, so here is a statistics. How much the global temperature has raised, right? So in here, in the circle, we have a chart of temperature from 0 to +2 and -2. You can see how the temperature is going to raise from 1919 to 2020, like in the last 100 years. The the continents are placed in the circle. We have Asia and India here. And I'm going to play this animation, and you'll see how the temperature is changing. Right here, on here, you can see the rise in global temperature. Here, the change in global temperature from 0, which is no change, to +1 or +2 in the last 10 or 15 years. It's 2006, 7, 8, 9, 10. You can see how much the temperature has changed. In some parts, the temperature has changed 2 degrees centigrade, right? 2 degrees centigrade. In some parts, it's 1 or 1.5. So in the last 100 years, we have seen 1.5 to 2 degree rise in our global temperature, which is like when you go to sleep and wake up next day and your body temperature has raised 2 degrees. How would you feel? It's called fever, right? So our Earth now has the fever, and we should treat it. We should consider the effects of global warming, adapt, and try to change something to fix that. Okay, so the same data is now here in the linear chart from 1850 to 2017. You can see the same data. Most of the time, the temperature has raised or changed from 0 to 1.5 or 2. That's an average, not for a particular country or particular region. It's an global average. Right. But what causes this rise in temperature in last 100 years? Let's consider some factors. Did our sun cause the rise in temperature? No, our sun is not changed for last 100 years. The amount of sunlight that we receive and the orbit of our Earth around the sun is not changed. It's still same, and there is no heating effect, change in heating effect from the sun. Now, what's the next factor? Did the volcano change anything? No, we did not have a lot of volcanoes in last 100 years, even if there is a volcano, we'll see a slight cooling effect when the dust and the particles are in the atmosphere. It blocks the sun, and it gives a little bit of cooling effect initially, and then the temperature will rise back. So volcanoes are not the reason. I'm trying to match a reason for this increasing temperature. What's the next factor? Did the aerosol, the tiny particles in our atmosphere, increase the temperature? No, it actually cooled down our temperature because aerosol particles will block the sunlight and stops the amount of sunlight entering into our atmosphere. So aerosol or the pollutants in the air is not the direct reason for the increased temperature. What's the next factor? Okay, did the change in land use increase the temperature? When we cut down a lot of forest, a lot of trees, it may cause some adverse effect in our greenhouse gases, but cutting down the forest is not the direct reason for global warming, because once you put a plain land, an open land, it will reflect the light back into the space. It will actually give a cooling effect for some extent. The next factor that we should consider is ozone. Did the hole or depletion in ozone cause the temperature change? No. Ozone may cause some rise in temperature, but it's very small effect in the lower atmosphere. But what actually causes the global warming is the rise in the concentration or the amount of greenhouse gas in our atmosphere. You can see this red line, this plot, matches exactly with the temperature. The concentration of greenhouse gases or the amount of greenhouse gases in the last 100 years will match exactly with the temperature change. So that is the reason for our climate change and global warming. And we're going to focus on those greenhouse gases, right? Okay, what is greenhouse effect? It is a sunlight entering from the sun into our atmosphere, right? Sunlight entering from our sun into atmosphere. Most of the sunlight will be reflected back to the space by the surface. Some of the light will be absorbed by the surface and radiated back as heat, right? So like in the daytime, when you park your bike or car in the sunlight, it gets hotter. Right? It's too hot to touch. What happens in the night? The bike or your car cools down, right? What happens to the heat? It receives the heat from the sunlight during the daytime, and in the nighttime, it reflects the heat energy, or it radiates the heat energy back into the atmosphere. Those greenhouse gases in the atmosphere is what receives that heat from the surface of your materials or the land. So most of the heat is absorbed by the greenhouse gases and reflected in all directions. That is what causes global warming. Global warming is actually good, right? Without these greenhouse gases, the Earth will be should have been very cold, right? The Earth should have been very cold, and we couldn't even survive. Some amount of greenhouse gases will give a nice, pleasant weather that we are enjoying now, but too much of greenhouse gases is what causing the climate change. Okay, so what are the amount of sunlight that entering and exiting our atmosphere? So here's the sun. 54.4% of the light is entering into our atmosphere, which actually reaches the surface. The remaining 23 is absorbed by the greenhouse gases in the atmosphere, or the other particles in the atmosphere. 29.4% is reflected back into the space. We are not receiving it, it's reflected back. And out of these 54 percentage, 86 or 85.9% is radiated back into the surface, right? It goes back like this. The Earth's surface radiates the heat, and the greenhouse gases absorbs the heat and radiates back to the surface. So it's not going anywhere. This is happening every day for last hundreds of years. All of the sunlight that the Earth is receiving is not going away. It's keep on hitting the surface, right? That's the global warming. And the remaining 14% could be going into the space. Right. So now we're worried about this 86% that the greenhouse gas is keeping and causing the heating effect. What are the greenhouse gases? The very common greenhouse gases are carbon dioxide, methane, nitrous oxide, and some fluorinated gases like CFC, chlorofluorocarbon, or hydrofluorocarbon, right? Carbon dioxide, let's keep the carbon dioxide at 1%. The potential of carbon dioxide in causing the global warming is 1%. Let's arbitrarily fix that. And compared to the carbon dioxide, the methane, nitrous oxide, and the other fluorinated gases are very potential, and they can cause a lot of global warming. But humans are emitting a lot of carbon dioxide, like 76 to 80% of the gas that we are emitting is carbon dioxide. And that is why carbon dioxide is a major gas that contributes to the global warming. It's not the other gases, but the carbon dioxide, because the amount of carbon dioxide that we're emitting is too high, and even it's a less potential gas, the amount will make the global, the atmospheric temperature shoot out to positive 1.5 or 2 degrees centigrade across the globe. Okay, now let's see how the carbon dioxide is emitted into the atmosphere naturally without human cause. Right? Who puts the carbon dioxide in the atmosphere in the first place? You know, humans are emitting a lot of carbon dioxide from industries, from transportation, from burning fuel. But naturally, how did the carbon dioxide end up in the atmosphere? There are two ways carbon dioxide enters into the atmosphere. That's called carbon cycles. The first one is a long-term carbon cycle. The second one is a short-term carbon cycle. We'll look at both of them before we discuss how humans are interfering these carbon cycles. Okay, so once upon a time, when the Earth was formed, probably 4 billion years before, when the Earth was formed, it took a while to settle down in a shape that we are seeing now, the spherical shape. Right? In this process of the formation of Earth, a variety of atoms and molecules, here are the elements in the periodic table. The variety of atoms are stored in different reservoirs, right? Different places, like atmosphere, our air, hydrosphere, that is our water, lithosphere, that is our land. So all of these elements are stored in these three reservoirs. But we know atoms and molecules do not stay in one form forever. They change, right? Carbon is one of them. carbon atom can take many forms. It can move from one compound into another compound, and it will never stop. It will never get tired. You and I are made of carbon-based molecules, right? Our body's made of proteins, um, blood, all the cells, they're all made of carbon-based molecules. So when we die, the molecules will move into another system. They travel in an endless cycle. Our body will not rest in peace. It will be recycled into the nature, right? There is no rest in peace for our body. It may be RIP is for our soul, but not for our body. Our body is very recyclable, right? All of the atoms will be recycled, molecules will be recycled. But when we try to stop the cycle by storing the atoms and molecules in one form for a long time, that will put every other living organism at risk, right? When you try to store some of these molecules in your fridge or in your house in the form of plastic, in the form of furniture, in the form of material, you're not allowing these compounds to recycle, right? So storing the molecules and atoms in one form for a long time will cause a risk, and that is what we have been doing for the past few centuries. Okay, there are two ways nature can recycle the carbon. The first one is the long-term carbon cycle. It takes hundreds of millions of years for this type of cycle to recycle a carbon atom or carbon-based molecule. It's a long-term cycle. It starts from a volcano. Volcanoes can emit carbon dioxide, right? It it burns the sediments under the ground and emit the carbon in the form of carbon dioxide into the atmosphere. When you burn something, it'll produce carbon dioxide, the most oxidized form of carbon, right? A prolonged and a continuous volcanic eruption that lasted for thousands of years could raise the atmospheric carbon dioxide level dramatically. That's what happened in the past. Maybe millions of years before, there were a lot of volcanic eruption, and that put all of the carbons from the lithosphere, from the land, into atmosphere. And increase in this carbon dioxide, the greenhouse gas, trap all the heat from the sunlight. So volcanoes are the major reason in the past, not now, in the past, for the global warming. And this increase in temperature uh, happened many times long back in the history of our planet. Volcanoes above and below the sea erupt and emit carbon dioxide that causes climate change, increase the temperature, and put most of the plants and animals to mass extinction, right? Animals and plants die. It, Volcanoes caused global warming in the past, and the rising temperature caused mass extinction. All the plants and animals died, and the hot climate lasted for millions of years. That's called the warm age. And then, in a very slow process, probably hundreds of millions of years, the water in the ocean absorbed the carbon dioxide, right? It's a very slow process, and that lowered the temperature, the global temperature for the lives to reborn, right? It's a very slow process. And once the carbon dioxide was removed from the atmosphere, there is no greenhouse gas, and the temperature will, the light will be reflected back into the space, no global warming, and it's called the cooling effect. And this lowering of temperature allowed the lives to reborn, like plants and animals reborn, Plants absorb carbon dioxide. Again, that's a very slow process. It takes some millions of years to remove all of those extra carbon dioxide from our atmosphere by the plants. When the plants were back, they were eaten by the animals and life evolved. But some other geological events like flood, soil erosion, tectonic movement can cause these living things, plants and animals, to die and go into the ocean, deep into the ground. And that removing of carbon dioxide by the ocean, by the plants and animals caused a freezing temperature. If you remove a lot of carbon dioxide, the earth will go to a freezing temperature that is called ice age. So in the past, the earth had experienced many hot climates and ice ages and several mass extinctions. All of the mass extinction, I think there were 5 mass extinction in the past. All of them were related to the climate change and global warming or freezing temperature. Once the plants and animals died, they become fossil. They go deep into the ground. Our underground is like a pressure cooker. With the plants and animals deep in the ground, the pressure and heat will cook them into fossil fuel. A lot of pressure, a lot of heat will convert these organic matter, the fossil, into fossil fuel, that is coal, oil, and natural gas. Again, this takes hundreds of millions of years. It's not a change in a year. It takes hundreds of millions of years. If there is an ice age, the ice age will last for millions of years, and if there is a hot age, that will last for millions of years. So the life is not possible in both extremes. In a very high temperature, in a very low temperature, the life form is not possible on Earth. So we need that ambient temperature that we're experiencing now. In the last few million years, we did not have a very hot climate. We did not have ice age. So we are lucky to live in this period of the Earth. Okay. Now, when the fossil fuels are underground, suddenly one day they will be emitted by the volcanoes back into the atmosphere. Right? That's how the carbon circulates in a cycle. From volcano into atmosphere, from atmosphere into ocean and plants, from plants into animals, and then into fossil fuel, and then back into atmosphere. And that's called a long-term carbon cycle. Okay, so we're not storing the carbon dioxide inside one particular form for a long time. Now, what do you think is the percentage of carbon dioxide in our atmosphere today, in present days? What is the percentage of carbon dioxide in our atmosphere? Take a guess. What percentage of our atmosphere is made of carbon dioxide? Take a few seconds to think about it. If you want, you can even type on the chat. I'm listening or I'm reading your chat. Okay, so some of you said 0.04, and that's the right answer. So if you said D, that is the right answer, 0.04, right? Our atmosphere is mostly made of the other gases. Carbon dioxide is very, very little amount, 0.04 percentage. So I'm just checking if everything is working well. So I asked a question. Okay, now our atmosphere is mostly made of nitrogen, which is 78 percentage, oxygen, which is 21 percentage, and together they make the 99 percentage of our atmosphere. The remaining 1 percentage is the argon, the other gases, and the carbon dioxide, the potential greenhouse gas. We are emitting a lot of it, but everything will go into this 0.04%. It's a very small amount. So changing this amount will cause a lot of effect in our planet. There is no way to control the carbon dioxide in our atmosphere. Any change, a small raise in this number could throw all of us into the ocean. That's right. It's like your body temperature can be adjusted by a small tablet, small pill. The size of the pill is very small, but it can adjust your temperature. It can raise your temperature to positive 2 or 3 degree Fahrenheit or negative 2 or 3 degree Fahrenheit, right? Carbon dioxide is like that. It's like the knob in your AC. You can turn the amount of carbon dioxide. You can adjust the amount of carbon dioxide in the atmosphere that will change the temperature. You can lower the carbon dioxide that gives cooling effect. You can increase the amount of carbon dioxide in the atmosphere that gives the heating effect. Now we'll see in the second half of this webinar in a video how the pressure and temperature changes the physical state of carbon dioxide and how the global warming is caused by the carbon dioxide. But for now, the second type, the second carbon cycle is called a short-term carbon cycle. It only takes 100 years to recycle a carbon, right? And this, the previous one, the long-term carbon cycle circulates the carbon through lithosphere, hydrosphere, and atmosphere, but this one mainly involves biosphere, or simply life. The carbon that is inside you and me and in every other living organism. It starts from plants. Plants take the carbon dioxide from the atmosphere. That is the only source of carbon for plants. Right? If you see a plant, it's fully made of carbon-based molecules, but all of those carbon come only from carbon dioxide in the atmosphere, not from the soil, not from the water, not from the nutrients. It's only from the carbon dioxide. So it is a good absorbing material. So planting more trees will remove the carbon dioxide from atmosphere. And it takes sunlight to build the structure. And this carbon that enters into the plant will move through the food chain. Animals eat the plant. It takes the carbon from the plant. Plants actually take the carbon dioxide from the atmosphere, water, and nutrients from the soil, and energy from the sunlight to prepare the food for every one of us, right? And build the structure. All of this structure is built from that carbon and energy. So the energy from the sunlight is now stored in the covalent bonds in carbohydrates. Inside the plant, there are a lot of molecules, a lot of covalent bonds, and those are the storage of energy. The only energy that we all have, that every plant and animals have, is the energy from the sunlight. We're not taking energy from the land. We're not taking energy from water. We're not taking energy from the atmosphere. We are taking energy only from the sun. That's the only source of energy. Everything you use now, your cell phone, your computer, everything is from the sun. I'll explain how. So the sunlight is now converted into a chemical bond called a covalent bond in the carbohydrates. And then the inorganic carbon dioxide is now turned into an organic compound called sucrose, fructose, cellulose, and all these organic molecules. This very process forms the foundation of this fast biological carbon cycle. When animals eat the plant, the energy go into the body of the animal. So the animal is actually taking the energy from the sun through the plant. And then the food chain continues. Another animal eats that, and the energy goes into this animal in the form of sugar or carbohydrate. The food chain continues. And all of these animals put the carbon dioxide back into the atmosphere. It was initially from the atmosphere. These animals uses the energy and releases the carbon dioxide back into the atmosphere. Right. And that energy is originally from the sun. The light was converted into chemical bond, like I said, and our body uses the light in the form of sugar as energy. And so each one of us have a little sun inside us. That's true. And when animals die, the microorganisms eat the animals, like fungi and bacteria eat the animals. They burn the carbohydrates, like us, like we eat food and burn energy. Microorganisms do the same and releases the carbon dioxide back into atmosphere. And these animals, these microorganisms, put the remaining organic matter into soil in as nutrients. So these microorganisms are the recycling unit of our earth. So don't kill them. We have to kill them, right? Coronavirus is a microorganism. Okay, now the nutrients are again going into the plant and the cycle continues. This is a short-term carbon cycle. This cycle is very good, very productive. It gives life. It moves the carbon atom. But we, Homo sapiens, or human beings, enter into the carbon cycle and destroy them. And let's talk about how we do that. I'm going to stop showing my slides. And I'm just going to talk like this for a while because I want to give this message. Okay, so we have seen a lot of living species. If you put all of these living species in a huge book like a telephone directory or dictionary, human beings will be a very small part of it. We only lived for last 2 million years, right? If you like the last in the book, human beings are like the size of the full stop on the last page after the last word. They're a small part of the book. Every other living organism lived before us. They obeyed the rule of nature and they never stopped or broke the carbon cycle. We human beings break the cycle, these two carbon cycles, the long-term and short-term carbon cycle, in every transition and leave a huge carbon footprint. The way we live in the last few centuries has damaged both the long-term and short-term carbon cycles. That's true. Number one, we cut the forest and we never planted enough trees. So there's not enough plants to absorb the carbon dioxide from the atmosphere, a huge break in the carbon chain. Less number of trees is equal to less food for animals and more carbon dioxide in the atmosphere. Then we use pesticide and put fence to our farms so the other animals cannot take food from us, cannot take carbohydrates from us. Again, a break in carbon chain. You're not allowing the carbon that is in the plant to go to the animals. And then what we do? We stock the limited amount of food in our own market, in our own refrigerator, in our own house. So that is another major break in the food chain. We are not allowing the food to go to productively go to the other animals. What else we do? We use the dead trees to make furniture. I'm sitting on a dead tree, right? My table is a dead tree. We use these stuff that are not the part of the healthy cycle. As we do this, as we build furniture, we are not allowing the food to go to the microorganism. If you keep all the dead trees inside your house, the microorganism that's supposed to eat them are starving, right? Then we make plastic out of carbon, a huge mistake. We are making plastic out of carbon that never decomposes, that never goes back to the carbon cycle. We transfer the plastic and other uneatable material into ocean that kills fish. Plastic cannot be recycled for thousands of years or hundreds of years, so it stays in the ocean and kill all the fishes. So every time we manufacture a lifeless thing, we are stealing the carbon away from the biological cycle and storing it in one place. Like I said, if we store an atom or molecule in one place for a long time, that will put a lot of other living organisms at risk that may cause a mass extinction. Look at the stuff around you in your own house. How many of them are made of carbons? Your water bottle, your cell phone, your computer, everything has carbon in it. Those carbon should have been gone into the productive carbon cycle. So how long do you think those materials will decompose? Probably hundreds of years, right? So this itself is a big fracture in our carbon cycle. Let's look at the more dangerous and a big planetary size problem that we are causing. We dig fossil fuels like coal, oil, and natural gas and burn them to release the carbon dioxide. Guess what does it? Volcanoes do that. Volcanoes are the one that dig all the sediments and put into the atmosphere, but we are doing it now. In recent days, we remove the coal from Earth, we remove the oil from Earth, and burn them to put the carbon dioxide in the atmosphere. So every one of us are mini volcanoes. Every our home, our house, our cell phones, our car, our computer, everything is a mini volcano that puts a lot of carbon dioxide directly or indirectly. Like I have a cell phone, I'm using a charger. That the electricity for the charger comes from some thermal power plant which uses coal, right? So directly or indirectly, we are putting carbon dioxide into our atmosphere. So we are digging this fossil fuel and burn them into atmosphere. We convert the million-year-old fossil fuel, like we saw in the long-term cycle. It takes millions of years to convert a fossil into fossil fuel, but we are burning the fossil fuel into carbon dioxide in every second, throughout the year, throughout the world, nonstop. Right? So every year we release 185 times more carbon dioxide than what volcanoes do. Human beings are releasing more than what volcanoes do, 185 times. So this is an anthropogenic change. It's not caused by the nature, it's caused by human beings. So we call it anthropogenic global warming caused by humans. Carbon dioxide level in the atmosphere right now is 400 parts per million, which is a record high we have never seen in last 2 million years. That's how far human beings have lived. We have never seen in the entire history of our human beings this much amount of carbon dioxide in the atmosphere. And most of that were released only in last 75 years after the Second World War, after the Industrial Revolution. This has changed the atmospheric temperature to positive 2 degrees. This planetary scale, I'm a small person, but I'm causing a planetary scale change that will affect every other living organism, right? So this excess of carbon dioxide that we put in the atmosphere will stay in our atmosphere for hundreds of thousands of years. That makes our ocean to heat up, become more acidic. We'll see in the video how ocean turns into acidic when you mix carbon dioxide. The ocean acidification will be destroying all the living organisms in the ocean, mostly the shell forming organism. So our Earth's climate has significantly changed many times in the prehistoric period, in the past, in the millions of years before. It has changed, true, but it happened in a geological time. It happened in hundreds of millions of years. But now we're going in a very fast phase. We rise the global temperature 185 times than what volcanoes did in the past. That means we drive into a mass extinction 185 times faster than what happened in the previous 5 mass extinctions. right? So at the speed we go now, we'll burn all the fossil fuel by 2100, which is 2100, will raise the global warming, will raise the global temperature to another 2 to 4 degrees centigrade by 2050. The temperature rise will also raise the sea level, and the coastal regions will be under the sea. That leads to climate migration, meaning migration of animals and human beings due to climate change. We have seen migration, particularly in India, due to the COVID. People walk from one state to another state by foot, right? Because of the virus. But now, due to the climate, in the future, due to the climate, human beings and animals will walk or will migrate from their native place to a different place, from their city to a different city, from their coastal region to inland, inside the land. Right? So this movement of people will happen soon. When my child, he's 4 years old now, when he's still in the college, the temperature will be 2 degrees higher, and there will be a mass migration of people and animals, and it will change the life of everyone. Our children don't get a chance to live the same pleasant life that we got to live now. If we keep emitting the carbon dioxide into atmosphere, the climate change will go beyond the level of our resilience and adaptation. We cannot adapt to this if we go this fast. So, to flatten the CO2, to flatten the curve, you know how to flatten a curve. We're trying to do it for the coronavirus. We try to flatten the carbon dioxide curve. We need to expand our strategic of using cleaner energy like solar, wind, hydropower. But that's not enough. Not putting the extra carbon dioxide is not enough. We also need to remove the carbon dioxide from the atmosphere, which is a negative emission, right? Uh, and that is a bit more ambitious, but it is much needed to slow down the climate change. So in order to achieve these negative emission, we need technological advancement and economic environment that promotes these activities. I'm going to show you some examples of how to remove carbon dioxide from the atmosphere. Okay, I think you're seeing my slides now. Okay, so this is how much carbon dioxide we put from different sector. 28% greenhouse gases, not just carbon dioxide, but the greenhouse gas. 28% from transportation, 10% from agriculture, 20% from industry, 10% from other commercial and residence, and 32% from electricity, how we use our electricity. Right? So if you could change any of these, it could slow down the global warming and the climate change. Okay, there are a few strategies. One is natural, and the other one is technological to remove carbon dioxide from atmosphere. Now, this one is a very new and ambitious way of removing carbon dioxide. Instead of using fossil fuels, the coal and natural gas, use the biological source of energy like trees and other biomass to give energy to our house or industries. And once it's in the industry, if the carbon dioxide is released into atmosphere, try to capture that and store it underground. Right? You can store the carbon dioxide in the empty space where we removed oil and coal. Right? So put the carbon dioxide back into the ground, into a cycle, and then use the clean energy to your house or to your transportation, to our, to to any use. You can also apply tax for using carbon. If someone is using more, if someone is emitting more carbon, it could be a country, or it could be a city, or it could be a house. If somebody is using more carbon, emitting more carbon dioxide, we can tax them and use the tax to combat the climate change, or to invest in a clean energy, or to help people that are affected by the climate change. It's something like, if you go out without a mask, you'll get fined, you'll get a penalty, and those penalty amounts should go to help people who are affected by the coronavirus, or purchase masks to those people. So that's how the tax work. It is a way you can dump the carbon dioxide into the atmosphere, into the lithosphere, uh, capture the carbon dioxide from the industry, separate, and re-inject into the place where you removed the fossil fuel from. And this is, like I said, very new technology. And you, as an engineer or a science student or faculty, have a lot of scope in doing research in the carbon capturing and storage projects. In the world, only very few countries have been doing this in a commercial scale, and it should be done in a lot of other countries. So to capture carbon dioxide from industries, I give one example that I admired as a scientist, as a researcher of nanotechnology. I've come across this particular article where they used nanoparticles, metal organic framework, nanostructure, which is basically a metal like a chromium, zirconium, zinc, and put an organic ligand on top of that, and place inside these chimneys to capture the carbon dioxide. This is very efficient synthesis. It uses silica matrix, which is not toxic, and it absorbs 35% of carbon dioxide, and it has a lot of stability. Just one small video before we talk about some solutions. Okay. Here's how you place the nanoparticles in the chimney, and then those carbon dioxide that comes out of the industry will be captured before it released into atmosphere. And then here's a metal organic framework inside this chamber, which interacts with the carbon dioxide and absorbs. This is not a covalent bonding. It just absorbs a physical absorbed carbon dioxide before it goes into the atmosphere. So if the nanoparticles take the carbon dioxide, you can remove the carbon dioxide from the nanoparticles later in a different procedure, and transport it and store it somewhere, or use it for a good purpose. Right? I'm not going to spend too much time on it. I know we are running out of time. We have a 20 minutes video to watch. So I'm moving out of this and talk about what you as an individual can do to meet the climate change. One strategy is mitigation. The other one is adaptation or suffering. Mitigation is how to reduce the amount of climate change. You can try to understand the science behind it, analyze how much carbon you are using, and use less energy in your house, cut down the amount of electricity usage in your house, or explore the availability of clean energy, use green transportation, recycle or reuse plastics, preserve trees and lands, and help or fund local initiatives to protect environment. These are some things that you can do right now to stop or slow down climate change. At the same time, you should also be ready to face the adverse effect of climate. You can monitor the air pollution, and have a plan for your family to adapt the climate change. If the temperature changes another 2 degrees, how is your family is going to adapt that? Protect children and your elderly from the immediate danger like storm, flood, drought, heat. We're going to see a lot of it in the coming years. So prepare your family to face that and change your lifestyle to meet the climate change. And as a college, as a university, as a faculty, you can try. I know this is a faculty uh, intense program, faculty development program. So you can play a critical role in preparing the society to adapt to the impact of climate disruption. You can add a few courses. If you're teaching a course, add a few chapter or a few laboratory experiment that is related to the climate change. So give the literacy, the climate literacy to your students before they graduate. Make sure they know what is coming in front of them, and change the operation and infrastructure in your own campus to face the climate disruption and be a role model as a college, as a university, to with energy efficient campus building, maintenance, and operation, and serve as a hub for local communities for testing and sharing knowledge. Work directly with the local communities, explain science to them, explain the implementation, the plans to adapt climate change. Also, engage the local leader, local communities in dialogue with identifying research opportunities and pilot tests on climate change. I know most of you are from Tamil Nadu or Coimbatore. We have a lot of opportunities in Coimbatore. Go get a sample from local water reservoir, lake, or river, and see how much it is changed in the last few years. And look at the air pollution, collect samples from the local city or village, and compare how the air pollution is changing, and collect samples of if you're a biological scientist, collect samples of plants and animals and see how they are adapting to climate change. There are a lot of uh, opportunities. If you're an engineer, you have a very good opportunity to do research in climate change, particularly in a carbon capturing technology. Okay, so I'm going to stop talking and ask you to watch a video. The video mostly consists of a lot of lab experiments that you and your students can try in your own laboratory. I think I have time. Let me ask the organizers. Can I still play the video?
Yes, sir.
Okay, thank you.
Sorry.
So so audience, I'm going to post a video link. Okay, let me see. Uh, in the chat window, if you go to the chat window, I'm going to post this link, and this is a 20 minutes video. I cannot show in the Google Meet because I tried it going to struck. The audio will not be very audible. So I would request each one of you to use the link that I'm going to post in a few seconds. Go to YouTube to watch the video. We are still on the Google Meet. Do not exit. Do not go out of the meeting. Please stay. Please stay in the Google Meet while you're watching the YouTube video. And after 20 minutes, I'm going to remind you. You're going to come back to the Google Meet. I'll be sitting here. I'll be watching you. I'll take questions and then we'll get some feedback. So please do not go out of Google Meet, but use this link 5, 4, 3, 2, 1. It's on there. Try the link. Watch the YouTube video for the next 20 minutes.
Participants are requested to watch the YouTube video and please come back to the session, join the session, and have some question answer session. And after that, we will provide the feedback link. Please. The meeting has not yet ended. If you just watch the video and come back to the session. Thank you. Hope everyone watched the video. Sir,
Yes, I'm
are
here.
you on the line?
Yes, I'm online.
Uh, Sir, hope everyone watched the video, it seems.
Oh, thank you. And yeah, I think we can go to the question and answer session. Most of them are waiting for other things to do.
Yes.
So let's open the feedback or question and answer.
Yes. Dear participants, do you have any queries or do you want to pose any questions? You can put up in the chat box or you can feel free to ask with the resource person. Any queries?
Sir, it is necessary to make maps in single crystal form.
Say that again. The metal organic framework.
Yes, sir.
I don't think so. We can make a metal organic framework in a multi-crystal form, and you can also dope it with other particles. Like in this one, I showed they used the silica nanoparticles to encapsulate your metal organic framework.
Yes. Sir, I am also preparing ZIF,
Okay.
MOPS. I am interested to dope manganese oxides upon it
Okay.
with silver nanoparticles.
Okay.
Sir, can you guide me?
Um, I do not have something on top of my head now, but you can contact me with what you have in your hand, and then I can show. I'll share what I know.
Yes, sir. Yes, sir. Yes, sir. You just mail me your contact ID.
Okay,
Otherwise, you
it should,
post here.
yeah, it should be in my. You can search my name. You'll get my email ID.
Yes, sir.
I'll post it here if you want.
Yes, sir. We will provide your mail ID, sir.
Sounds good. Thank you.
Yes.
Any other
Thank
question?
you. Thank you, sir.
Thank you.
Sir, this is a question from Tyagarajan Meera.
Okay.
Can global warming produces viruses like corona?
Not directly, but rise in temperature could be helpful for the virus to spread faster. That's one thing. Microorganisms can be controlled by changing the temperature. Some microorganisms grow faster, even 1 degree rise in temperature. Some will not grow if you lower the temperature. That is why during the ice age, when we don't have a lot of temperature, most of the animals die. So temperature is directly related to the survival of microorganism and other lives. So yes, global warming can help virus to spread, but not it will not produce any new virus.
This is another question, sir, from Ms. Sona. Does natural carbon sequestration process interfere carbon cycle?
Um, in a good way, yes. So the natural carbon sequestration is, I believe you're talking about planting more trees. Yes, it interferes in a good way, um, because we already have a lot of carbon dioxide in the atmosphere. So if you increase natural sequestration by planting more trees, by stopping deforestation, it helps removing the carbon dioxide from the atmosphere. It actually uh, retain our carbon cycle. It won't damage, but it will retain the original natural carbon cycle.
Hi, I had a question
Yes.
in regards to. So, basically, my question is, we know that the man-made burning of the man-made fossils is responsible for the greenhouse gas, but and this is also now supported that in the lockdown we've seen a major improvement in in environmental conditions around the world. But how can we be sure that this greenhouse effect is not actually a part of a natural process of the earth in its evolution?
Yes, that is the major question most of the people have, and 97 percentage of the scientists agree to the fact that this global warming is caused by humans. So there's an anthropogenic global warming because the data says in the last 75 years, we have increased the amount of carbon dioxide locally and globally. Emission, right? The global emission of carbon dioxide has increased. And this global temperature has exactly matched with the pattern of increasing amount of carbon dioxide due to human beings. So it's been studied throughout the world from the satellite, in locally, in every industries, in the lab, that increasing carbon dioxide increases greenhouse gases. It is also studied that in last 75 years, during the industrial revolution, we have used mostly fossil fuels and burned carbon dioxide into the atmosphere. If it was due to nature, it should have increased in the last hundreds or thousands of years, but it was a steady rise in global warming, or steady maintenance of global warming in last few thousand years, except last 75 years. So it pretty much 99 percentage sure that it's an anthropogenic global warming.
Okay, thank you.
So there is another question from Mr. Anil Raj. What is the role of biomass transformation into chemicals in carbon cycle? Can we use it to close the carbon cycle?
Yes. So biomass transformation. So when you use biomass as your energy source, it is good. It's a carbon neutral. You're not putting additional carbon dioxide into the atmosphere. Fossil fuel that we are digging out of the earth is what causing additional carbon dioxide in the atmosphere, what puts more carbon dioxide in the atmosphere. But if you use the natural or biomass for your energy source, the carbon in the biomass is actually from the atmosphere. So biomass take the carbon through respiration, plant respiration, and you're using it to put it back. It's a natural cycle. It's a good cycle. So compared to fossil fuel, biomass transformation will close the cycle. Yes.
Sir, another question from Dilip Kumar Mishra.
Mhm.
MOFS always be a single crystal or in other form?
I think we talked about it to the same question.
Okay. And this is again a question from Dr. Jayapriya. What are the implications if COVID on greenhouse gases and global warming?
There is no direct relationship between COVID and global warming. We locked down for a few weeks, but still, we avoided going out. We avoided using transportation, and we used less fuel. That's true. It may be locally in your city, in your area, lowered the greenhouse emission, but we are talking about a planetary scale throughout the year emission of carbon dioxide. So we have to study the entire year of emission. COVID is here only for a few months. Locally, some studies showed that there is a less emission of carbon dioxide and the air pollution is less, but we have to study throughout the year to verify it. And it's actually not because of COVID virus. It's because of not going out. So those are two different things. You can lock down even in the regular days without COVID, without the virus. That will help a lot.
Dear participants, any queries?
If you have any question, you can put in the chat, and then I'll get them through the email. I can answer them through the email if that's okay. I know most of you are uh, going impatient, and I'm apologies for taking some of your time.
So, shall we wind up, sir?
Yeah, sure.
Let me call upon Dr. Deepa to propose a vote of thanks on behalf of Department of Science and Humanities. Deepa ma'am, session is over to you.
Yeah. Before proceeding with my vote of thanks, another important announcement is there is another interactive webinar scheduled tomorrow at the same time between 3:30 to 4:30. We expect same amount of participation, if not more. Let me propose a vote of thanks. Respected resource person of the day, Dr. Sarana Ramaswamy, virtual CEO and Secretary, Dr. P. Krishnakumar, NCI, beloved Principal of NIET, Dr. P. Manielson, Head of the Department of Science and Humanities, Dr. Shalini Kamala, Head from various engineering, Secretary Officer of NIET, Mr. Sudarmani, Media Team of NGI, Mr. Roshan and his team, academicians from different countries, participants, I express my gratitude for your presence in a busy schedule in the challenging period. Once again, I express my heartfelt gratitude to our resource person, Dr. Sanna Ramaswamy, for his acceptance of the presentation. Thank you all.
Thank you so much for having me. You all enjoy your evening. I'm going to start my day, and I'll try to see you in another occasion. Thank you, Dr. Brinda, for inviting me. Thank you, Head of the Department, Principal, and CEO of Nehru Groups of Institute. It's been a pleasure talking to you all.
Sir,
Yes.
sir, could you please share your mail ID? Because participants are asking, want to interact with you in future.
Yes, I'm typing right now. Okay, it is. Okay, it's on the chat window.